Have you ever stopped to wonder what makes our computer networks, our microwave ovens, our cell phones and video games, even our subway systems run? How does it get to us, and who makes it work? Of course, we're speaking about electricity, our most convenient form of energy. Although we use it every day, we rarely think about the massive collection of generation, transmission, and distribution systems that engineers have designed to power our world. Did you know that you could trace a wire from Ontario, Canada, all the way to Florida? So important to our daily life is this complexly interwoven system that the National Academy of Engineering called electricity the workhorse of our modern world, and ranked our electric power system as the #1 greatest engineering achievement of the 20th century. But who are the people behind this amazing achievement? Power engineers. Today, engineers are designing new components and new strategies for operating our power systems to make it even more efficient, better for our environment, and smarter than ever. Though we don't think about it much on a daily basis, we are occasionally reminded of our total dependence on the electric grid when the lights go out. As heavy usage stresses the grid's components or severe weather threatens them, power systems can, and sometimes do, fail. Another problem is that much of the electric power infrastructure is nearing, or has already exceeded, its original life expectancy. On August 14, 2003, 50 million customers lost power during a major blackout in portions of the northeastern United States and southeastern Canada. Some customers were without power for 2 days. Vehicle traffic and commuter trains were paralyzed in large cities. People were stuck in elevators and on amusement rides. Subway trains ground to a halt in pitch-black tunnels. Without refrigeration, food spoiled. The question on everyone's mind was, how did this happen? And could this have been prevented? Some experts believe that large, complex systems, like our power generation and delivery system, can't be 100% reliable and will always experience some failures. Others believe that the risk of outages can be minimized, maybe eliminated, through advanced control systems, state-of-the-art technology, and better communication. Companies like S&C Electric are overcoming these problems by employing a variety of engineers. Their creative designs have led to remarkable solutions to overcome many of these challenges.
This is the Interrupter Pulse Closer, the most exciting product that S&C has introduced in our 100-year history. It uses electronics to make decisions in milliseconds about what should happen to the power system. Combines that with high-speed Internet protocol-based communications to be able to talk from device to device. It has electromagnetic mechanisms that can close and reopen in 1,000th of a second to just test the circuit to see if there's a short circuit there. The advantage of this device is by talking to each other. If there's a disruption on the power system, our devices combined with our software called IntelliTeam can rearrange the system to isolate the problem and turn the lights on everywhere else in the system so that consumers have very few outages. And it can do it faster than humans could react.
Today, we're using more power than ever, and that means we're sending more CO2 into the environment, contributing to global warming. Meanwhile, our power systems are getting older. So too are the people who build and maintain our power plant.
The workforce has matured very much over the last couple of decades, and more people are retiring out of the business. This creates opportunities for new engineers to come into the business and make their mark in a business like this. There's a tremendous need for people at all different types of engineering in the power industry, whether it's civil engineering, electrical engineering, protection and control engineering, information technology. All of these different disciplines combine to make the power industry work. And so there's a tremendous opportunity today for young people to get into this business.
What does that tell us about the future? Who will continue to improve our power system? Could we run out of fuel for producing electricity? Could electricity prices climb too high for us to run our appliances, our air conditioning, our lights, our computers, TVs, or video games? Could our power grid fail due to heavier loading in the future? In downtown Chicago, power engineers at Commonwealth Edison recently completed a major project designed to prevent power grid problems. Since load demand increases over time, ComEd power engineers use forecasts to predict the future load levels.
I look out in future years, maybe 5-10 years out into the future to see our power needs here at ComEd. And I do some analysis, and then that analysis helps to determine what we need to build now as far as transmission facilities are concerned for our future needs.
In 2008, Illinois Institute of Technology began a $12 million project, partly funded by the U.S. Department of Energy, to implement the perfect power prototype on the university's main campus in Chicago. This smart grid demonstration project aims to deliver perfect reliability, improve energy efficiency, and reduce peak demand on campus.
This is a really cool engineering example here. This is the Illinois Institute of Technology campus. You can see the buildings here, and the colored lines represent the electrical wires.
Prior to a new system, IIT's campus suffered from numerous electrical outages. Engineers using modern equipment, fiber optics, and innovative new approaches virtually eliminated campus-wide blackouts with computerized solutions, saving the campus up to $500,000 a year.
The new system, designed by power engineers, is a looped system. This is called the high reliability distribution system.
Problems that previously called for hours of troubleshooting by electricians are now resolved in milliseconds.
The entire process of isolating the bad section of electrical distribution takes just 1/10 of a second.
My name is Paul Papst. I'm an electrical engineer here at S&C Electric Company and a 2007 graduate of Purdue University.
As we develop cleaner, renewable solutions to power our world, it takes innovative engineers to make them a reality.
Products like these are at the forefront of technology for implementing renewable energy and bringing it from the wind turbine and into your home and into your iPods.
These are just a few examples of how engineers can improve our lives. Reliability, safety, and sustainability are some of the biggest challenges we face in the electric power industry, and power engineers are busy designing potential solutions. But we need more engineers to tackle these challenges. You could be the one to help develop environmentally friendly renewable sources. You could be the engineer who helps us use electricity more efficiently. You could be the engineer who helps us switch to more electric vehicles.
So this is one of the pieces of equipment that we as engineers can use to solve problems, where every installation, every customer has a different requirement, and you bring all your tools together, everything you've learned in class, learned in the field, and the equipment you have available. So this is the kind of equipment that we've used to solve our problems. I can't wait to see what you guys will come up with in the future for the new problems that'll arise and the new equipment you'll have to work with.
Engineers turn dreams into reality for the good of humanity. Engineers are problem solvers. The engineering profession builds societies and helps us use our resources more efficiently. Engineering is a creative activity, challenging, rewarding, and within reach.
I studied at Illinois Institute of Technology right here in the south side of Chicago, and I especially focused on electric power systems. Why? I think it's exciting, it's challenging. Every day there is something new. There are problems that need to be solved with new ideas. I get to use what I learned in school, use creative thinking, problem solving, and as cheesy as it sounds, help make this world a better place. As engineers, not only do we help solve problems that are existing, but we step outside the box, we use our imagination, and we try to come up with solutions to problems that have not yet been identified to help make our environment, our world, and most importantly, our lives better, cleaner, greener, more efficient, safer, and more fun.
Successful engineers plan ahead to prepare for future challenges. If you are a student, then now is the time to plan your course selections to make sure you'll be prepared to study engineering. You can start by talking to your teachers and guidance counselors about the excellent career opportunities for people like you, willing to work on the challenges facing society. Engineers are inventors. Engineers are innovators. Engineers are leaders. Are you?